We are continuing chapter 8 by now looking at what are some other things that we need to examine to determine if our model is really a good enough model for our data. So as you know, because this is real life data, the model that we are making is never going to be perfect. Regardless of the line that we are able to draw, nothing's going to be perfect because this is real life. Some points might fall above the line, some points might fall below the line. That leads us to our first definition for this lesson, and that's the definition of a residual. A residual is the difference between the observed value, which is your original y value in the data table, and its associated predicted value, or y hat. In other words, if we took the x value and we plugged it into our y hat equation, the residual is the difference between what the actual table said and what the model said. And so in equation form, to find a residual, we take our observed value minus our predicted value. Now the letter that we use for residual is the letter E. I have no clue why, but that's the letter your book uses. So the letter E is the letter for residual, and it's found by taking the actual y from the data table minus the y hat value found from using your equation. And we're going to be using this today. Let's look at some more information about residuals. So this is just some basic information. If you have a negative residual, that means that your predicted value is bigger than your observed value. Okay, so I'm going to make a little note. It means that y hat is bigger than y. If you get a positive residual, that means that your predicted value was too small. We underestimated. In other words, if it's positive, that means that the observed value is bigger than the predicted value. So similar to what we did with standard deviation, we square the residuals and add those values up. And the smaller the sum we get, the better the line fits the actual data. And so the line of best fit is the line for which the sum of the squared residuals is smallest, which is also why the line of best fit is sometimes referred to as the least squares line, is because it is the smallest squared residual value. So let's look at how we actually calculate residual. We're going to go through the process. So the first thing you do is you create a scatter plot and calculate the line of best fit. So this is our data. We're simply graphing x's and y's. My x's go up by 1, so I'm going to go ahead and just go up 1, 2, 3, 4, 5, 6, 7. My y's go from 1 to 17. So I'm going to count by 2's because I know I don't have enough boxes to count by 1's. So 2, 4, 6, 8, 10, 12, 14, 16, 18. All right, so we got 1, 1, 2, 5, 3, 7, 4, 8. 5 jumps way up here to 12. 6 is also at 12, and 7 is up at 17. So as you can see, it's roughly in a straight line. To calculate the line of best fit, that's where our calculator does the work. So pick up your calculator, go to the stat button, enter to edit. L1 goes your x values, and L2 is your y values. Once you have that in the calculator, you press the stat button again, go over to calculate, and we need option 8. And so once you've done all of your enters and you've got all your data, it should look like y hat, because remember it's a model, is your a value is negative 0.71 plus your b value is 2.39x. So this is our important model, and we're going to need that model when we go to actually find the residuals. So this is the first step of the process for calculating a residual is to first find the line of best fit. Now, to finish finding residuals, we need to complete the table. So I recopied over the original x and the original y from the first slide. We need to fill in this column using our model. And again, our model was y hat equals negative 0.71 plus 2.39x. So what we need to do is we need to take each of our x's, 1 through 7, and put them in place of x. And whatever answer we get, our y hat, we record in that third column. So we're going to take negative 0.71 in our calculator. In our calculator, type in negative 0.71 plus 2.39 times 1. And you should get 1.68. And then you're going to do the same thing, but instead of a 1, you're going to make it a 2. And I got 4.07. Pause the video, finish filling in this column to make sure you did it right. When you start up the video, we'll check your answers. Okay, so you should have gotten 6.46 and 8.80. My pen's being dumb. 8.85, there we go. 11.24, 13.63, and finally 16.02. So now we need to fill in this next column. If you remember E, the formula is y minus y hat. So we're going to take y minus y hat for each row. So 1 minus 1.68 is negative 0.68. 5 minus 4.07 is 0.93. Go ahead and pause the video, finish the subtracting, and fill in that column of your table. Okay, let's make sure you did your subtraction correct. 0.54, then I had negative 0.85, and yes, the positives and negatives are important. 0.76, negative 1.63, and 0.98. Okay, so now we have to graph our residuals. So the columns that we are graphing, just so you make sure you have your correct columns, we are going to be graphing the x column and the residual column. So x's go on the x-axis, so we're still going to use the original 1, 2, 3, 4, 5, 6, and 7. The residuals go on the y-axis. So if you look, we have some positives and some negatives. The highest we go positive is 0.93, and the lowest we go negative is negative 1.63. So I'm gonna count by ones, but I'm gonna skip a line. So I'm gonna put 1 and 2 there, and negative 1 and negative 2 there. That way we have a little more space. We have the halves in there. So at 1, we're at negative 0.68. So I'm down here somewhere. At 2, I'm at positive 0.93. So I'm really close to 1. At 3, I'm at 0.54. So just a little above half. At 4, I'm at negative 0.85. So we're getting closer to the negative 1. At 5, we're at positive 0.76, so we're kind of right in the middle of those two. At 6, we're at negative 1.63, so we're more than negative 1.5. And at 7, we're at 0.98, so we're almost at 1. So, what do you notice about this graph? Do you see any patterns, or does it just kind of look like dots? If you look at this, you should see that there's no straight line, there's no curve. It's just kind of up and down, kind of all over the place. That's actually a good thing. If you see no pattern in your residual plot, then that's actually a good thing. That means that your line of best fit is actually a good linear model that should predict your data well. So we're going to do another example, just one. So again, we have to create the scatter plot and find the line of best fit. So I'm going to count my x-axis again by ones because I need to go up to 7. And my y's, this time I only need to go up to 9.9, so I'm also going to count by ones. So at 1, I'm at 0.1, so I'm way down here. At 2, I'm almost at 1. At 3, I'm actually at 2. At 4, I'm at 3.3. At 5, I'm at 5. At 6, I am at 7.3. Whoops, that was probably a little high. My pen's not so good at marking. And at 7, we're at 9.9, so we are almost at 10. Okay, so as you can see, we have our dots, they're kind of in a straight line. So we need to go back and we need to calculate that line of best fit. So go back to pick up your calculators, press that stat button, clear out that old data, put x's in L1 and put your y's in L2. And then press the stat button again, over to calc, option 8. And once you've hit your enters, you should have some numbers ready to fill in for your model. So our models always start with y hat. Our a value is negative 2.4. Our b value is plus 1.62x. Okay, so that being said, we're going to go and turn our page, and we're going to do exactly what we did before. We're going to fill in this column using that model we just found. Y hat equals negative 2.4 plus 1.62x. So pause the video, find all of your y hats, then come over here and do y minus y hat to find all of your residuals. And then we'll see how you did after you are finished. Okay, so let's check all of your answers. I got negative 0.78 and 0.84 and 2.46 and 4.08 and 5.7, 7.32 and 8.94. So those were all of my y hats when I plugged in 1 through 7. And then when I did all of my subtracting, I got 1.78, negative 0.04, negative 0.46, negative 0.78, negative 0.7, negative 0.02, and finally 0.96. And so we're going to graph this again 1 through 7. And then I'm going to do the same thing. I'm going to skip a line, mark it 1, skip a line, mark 2, skip a line, negative 1, skip a line, negative 2. So, and remember, you are graphing this column and that column. So at 1, we're at 1.78, so pretty close to the 2 mark. At 2, we're way down at negative 0.04, so that's just like barely below the line. At 3, we're at negative 0.46, so we're almost halfway. At 4, we're at negative 0.78, so we're like right there. At 5, we are at negative 0.7, so we're up just a little bit. At 6, we're back at negative 0.02, so that's just, again, barely under the line, under the x-axis. And then at 7, we're back at 0.96, which is almost at 1. So what do you see this time? I see, and hopefully you see the same thing, a very curved pattern. That is very bad. Curves mean that your linear model, not so good. So residuals help us to see whether the model makes sense. Okay, when a linear model is appropriate, nothing interesting should be left behind. In other words, there should be no pattern if a linear model was appropriate. But after we fit a linear model and we plot the residuals, we hope to find nothing. If you see a pattern, though, what that means is your data shouldn't have been used to find a linear model. If you look back at your scatter plot that we drew, you should see a slight curve in that scatter plot. That's why we had a curve in our residual. It means that we should have never made a linear model to begin with. So linear model okay means that you got dots just kind of all over the place with no pattern. Linear model not okay means that you have some sort of, it could be a curve, it could be any sort of pattern. It doesn't have to always be a curve, but there's a pattern, and patterns are bad. Now, we've spent most of this lesson doing everything by hand, and that is very time consuming, especially if, say, you have 20 or 30 data values to work with. So your graphing calculator does all of the work for you as well. So let's take a look at the graphing calculator instructions. So to create a residual plot, the first thing you need to do is enter your data into L1 and L2 because you need to calculate the line of best fit, which you already know how to do that. The minute you calculate the line of best fit, the calculator automatically calculates all the y-hats and it automatically calculates all of the e's. So that's something that the calculator takes care of for you. But you have to do this right here in order for the calculator to automatically do that. To graph the residuals, you're going to press second y equals, which is your stat plot button that we've used before, and hit enter. Turn on by pressing the enter key. The 6 graphs that are there, you want the first one. So go to the first one and press enter. Your X list should be L1. Go down to your Y list though, and you need to make that say resid. So you're going to press second stat. My calculator, it is option 7 that says residual or resid. However, I found that apparently not all calculators it's option 7. It's somewhere in that list. It should say RESID. You just got to search for it. Once you've put that in there and you've hit enter, then you press zoom 9 and you should see the exact residual plot that you would have found by hand. So I'm going to run through the one that we just made, example 6, using the graphing calculator, just so you can see what it should look like. But here's the instructions in case you need to refer back to them. So this is the exact data that we made the scatter plot and the residual plot just recently for. So now we're going to use the graphing calculator to create that residual plot. We are going to be going through the exact same problem we just finished, example 6, using the graphing calculator so you can see how a residual plot works. So as our instructions say, and we're going to go through all 5 steps, enter your data into L1 and L2. So I'm going to go to stat, I'm going to hit enter for edit. Remember, to get rid of the data, I arrow up, I press clear and enter, and then I do that again for L1, clear and enter. And so the X values were 1 through 7, 1, 2, 3, 4, 5, 6, and 7. The Y values were 0.1, 0.8, 0.8, 2, 3.3, 5, 7.3, and 9.9. So that's the first step, is to get the data in. Then the second step is to calculate the line of best fit. So again, we go stat, we go over to calc, and we go down to option, or you could have just pressed the number, 8. And so we hit enter until it calculates, and this was the equation that we found back on the first slide when we had the graphing calculator find our line of best fit. So now Once you calculate the line of best fit, it automatically calculates the residuals and saves them. But you have to see this screen in order for the calculator to do that. So now to graph them, we're going to press second y equals. We're going to hit enter. We're going to turn it on. I'm going to go down and I'm going to hit enter because I want the first graph. And this should say L1. Your Y list may or may not say residual. To get it to say residual, we're going to press second stat, and I'm going to go down, and you may have a shorter list here. You're looking for this guy right here. So whatever option says residual, that's the option you want. Mine's number 7, but yours might not be. So once you have all of those, then we're going to press zoom, and we're going to press 9. And that is our residual plot, which, if you think about what we just did for example 6, that's exactly what it looked like. And so that's how you create a residual plot using the graphing calculator. Okay, and so when you're asked to do this in your classwork that you're going to be doing, you can use the calculator and then you can just sketch what the calculator shows you on paper. Now, there's one other thing that we need to talk about in this lesson, and that's what's called the coefficient of determination. Now that we are able to calculate scatter plots, calculate the line of best fit, and determine if that linear model is okay to use and make predictions with, the final piece is to decide how well the model actually makes the predictions. So all regression analysis include what's called the coefficient of determination, also written as R squared. So coefficient of determination, and the notation is R squared. R squared shows what percent of the variation in Y can be accounted for by the variation in X. Or in other words, how well Y can be predicted using your X. So if there's a lot of change in Y, but that change is because you're changing the X values, then that means that your model is good at predicting. But there can sometimes be causes that cause your Y values to fluctuate, and it's not the changes in X's that cause that. R squared is always going to be a percentage between 0% and 100%. And the closer it is to 100%, the better the model is at predicting. And here's the nice thing. R squared can be found using the graphing calculator the exact same way that we found correlation. So when we put in L1 and L2, and then we go to stat and calc and option 8, correlation was R, the line of best fit was A and B. The fourth thing there that we've never used yet was R squared. Now we're using R squared. So, what I would do is go back to example, you know what, we're just going to do example 6. We'll save time. We're going to not do example 5, just for the sake of time. Go back to example 6, which was the most recent one you did, and the data should still be in your graphing calculator, and just find R squared. And so if you go back, we already should have into L1 our X data and our Y data from example 6. So press stat, go over to calc, and go down to option 8. So again, it's still stat, then calc, then option 8. And we're looking for R squared. Now your calculator should tell you that R squared is a decimal. And in this case, it should say 0.96. But we think of R squared as a percentage. So if we multiply by 100, this comes out to be 96%. So that's really, really close to 100. So that means that there's very little outside influence on our data. So that is a good number to get. And so that's the end of the second lesson for chapter 8.